All right, let's get started. So hopefully you're all here for CS365 programming languages and systems. If not, feel free to stay. It's very entertaining. At least I think so. At least educational. Um, what we're studying this semester in this course is a variety of programming languages. This is the one course where you will learn Java. No other course in this curriculum guarantees that you will be exposed to Java. We will spend the first half of the semester on Java, and it will seem to go fairly quickly in the beginning, although that's it's a lot like C++, so I don't think that's going to be a big issue for many of you. We're also going to be looking at a number of language paradigms that you probably either have not seen before or have had only kind of a glancing familiarity with. So we will be talking about object-oriented programming. And you're probably thinking, well, I've used C++, I know what it's all about. But many of you have not yet really used inheritance, don't really know how it's implemented. That's kind of the systems part of this course where we talk about how things like inheritance get implemented. So we'll be touching certainly on object-oriented programming. We'll be touching on what's called event-driven programming. And that is also often known as graphical user interfaces. And event-driven programming turns out to be a very different kind of programming than the style that you're familiar with right now. So the way that you're familiar with writing a program is that you're in control. You call a function when you're ready to call a function. When you want input, you ask the user for input. You wait until the user provides you with input. With a graphical user interface, the locus of control changes. The user is in control. You'd have no idea what the next input is going to be. It might be some menu selection. It might be a button. You don't know. It might be voice. It might be a gesture. You have no idea what that next piece of input is going to be, but you have to be prepared to deal with any piece of input that comes in from the user, and you need to respond to it instantaneously. So instead of you being in control, the user is in control, and you're responding to the user rather than vice versa. And that has implications for the way that you write programs. Then we're going to be moving into scripting languages. Now, I understand many of you have seen them. Some of you have not. We will be considering Python in this course. I think that it is a good general purpose scripting language. It's widely used. It's an excellent introduction to scripting languages, and since you already know C syntax, it should be a relatively simple transition into scripting languages. And from there, we go into a paradigm that most of you will not feel so comfortable with, and that is functional programming languages. That is a paradigm that comes out of mathematics. It's based on calling functions, and it is based on recursion. So many of you are used to writing loops in order to accomplish things. In a functional programming language, you tend to use recursion to accomplish what a loop would use. So it's an example. To sum up the elements of an array, you're used to writing a for loop. But in a functional language, you would do that recursively. You would say that you would come up with a way to express it recursively. So you might come up with something like the sum. Whoops. I need to calibrate this for a moment, so give me one moment to calibrate. It looked like it was calibrated when I tested it a moment ago, but it appears that it is not. I never did know how to draw inside the lines. Okay, should take care of that. And there we go. So you might say something like the sum is equal to a sub 0 plus the sum of the array A from 1 to n, where n is the size of the array. And then at the end, it might be that the base case is sum equals A of n. So you're always adding. In fact, this isn't quite the right thing, so it might be more like if you were writing the function sum, taking A, you're summing from I to n. You might say if I equals n, return A sub n, else return A sub I plus the sum of A from I plus 1 to n. That would be a recursive way to sum an array. And yes, you may say that this looks pretty unreadable compared to a for loop, and I would agree. But there are other situations, like with binary search trees, where recursion is quite natural to use. And functional languages do have a place in industry. Every semester I get some comments that this is not used in industry, and you'd be dead wrong. For example, when you do your airline reservations, looking for using Kayak or something, the underlying reservation system is written in Scheme or Lisp. It's one or the other. And in fact, the people who wrote it started at MIT, and they blew away the competition by using the Lisp Scheme variant. They found that they could do things in a day or two that it took their competitors a month to do. And conversely, when they came up with a new feature that took them a couple days, it took their competitors over a month to come up with the same feature in a procedural language. Eventually, their competitors, the old Sabre system, surrendered and bought them out. So the next time I read that functional languages aren't used in the real world, well, I tend to just roll my eyes because they are. Yes?
Question. Do you recommend using functional languages for actual projects?
So when we get to them, I will, in fact, tell you that there are compelling reasons for using them. Now, there aren't that many programmers that do. The person who was the original creator of Yahoo Stores also did it in a functional language and wrote a very compelling case for why he also blew away his competitors by using a functional language. So the answer is, if the project was the right type, I would. It has to be the right type. And you also have to find people with those skills and be committed to it. Okay? I personally don't use it here in my research because it takes too long to train people how to use it. It takes about 6 months before you're fully comfortable with it. So by the time you're finished here, you will not be comfortable with it, and you probably won't enjoy it that much, but it's important that you be introduced to it. Okay? It is used in industry. You might find that you have to use it in a project. I found that I had to use it on my postdoc project. So I know I took it in graduate school. I had Lisp, thought it was useless. Spent 2 years working on it in my postdoc project, so I was dead wrong. And finally, we will cover concurrency. And we will be doing that again in the context of Java. Now, for those, how many of you are taking 360 this semester? Okay, and how many have taken 360 already? Okay, so it's better probably, I don't know. For those of you who are taking 360, it will turn out that we get to concurrency at roughly the same time that 360 gets to concurrency. So in 360, you will be using a pthreads library to do it. In Java, concurrency is built into the language, and therefore it is more seamlessly integrated than it is in C or C++. I find it a joy to use concurrency in Java. I do not find it a joy to use the pthreads library. It'd be interesting for those of you who've taken 360 to see what your opinions are. For those of you who are taking 360 this semester, hopefully you won't get too confused going back and forth. It's like learning Spanish and French at the same time. You have to get back and forth between the two. So those will be our topics. Half a semester on Java, a couple weeks on object-oriented programming, a couple weeks on GUIs, a couple weeks on scripting languages, a couple weeks on functional languages, a couple weeks on concurrency. So, where do you get information about the course? Information can be found at web.eecs.utk.edu/BVZ/CS365. Okay. If you go to that website, you will see that there are different goodies there, links to different things. So links to my general information, links to my lecture notes, links to homework assignments, links to previous exams, links to Piazza, links to the TAs which have not yet been updated, links to my plagiarism policy, please read it, I'll go over it briefly, and a pointer to a useful document on common Java errors. When you first start, that can be kind of tricky figuring out what the error messages are all about. Okay, so here is that website. And before I get into that, let me tell you that this class will be run differently than what you're used to, although if you took CS102 from me, it will not seem so different. So I run this classroom as a modified flipped classroom. I assign lecture videos at the beginning of each class that I expect you to have viewed before you come to class. In class, I will typically take a bit of time to go over any material that I think is difficult and needs some further explanation. And we'll be going over exercises, and we'll be going over homework assignments in class. So oftentimes I'll be simply giving you exercises to do in class. You'll work on them for some period of time. Then you will reconvene, go over the solution. Sometimes, as I said, those will be homework exercises. It's like freebies. And you'll simply be able to take that, copy it down, put it into your homework. Sometimes there will be pretty much a full lecture, like when we get to the model view controller model, which is with graphical user interfaces. It'll be a full day lecture because I know from past experiences that it's really messes with your minds and it's hard to kind of get it straight, and so we'll kind of work through an example the entire day. So it varies from day to day how much I talk, how much you're doing stuff in class, but my philosophy behind the flipped classroom is that it's easy enough to listen to me on your own time. What's really valuable and where you really learn is when you're doing. And what often happens is that you get this thing that when you're listening to me, it all seems clear and obvious, and you leave thinking it's the easiest thing in the world. And then you start working on an exercise, and that reality distortion field dissipates, and you realize you don't really get it. And now you're stuck. But if you're in the classroom doing it, you can raise your hand, I can come around and I can get you unstuck. Or you can talk to your neighbor and you can get unstuck quickly. Whereas if you're off by yourself or with a friend, it might take a long time to get unstuck. The analogy I like to give is that of golfing, because I'm a golfer. So you can watch videos of golfers, and they will have beautiful swings, awesome swings. And you can watch as many of those videos as you want. And you get out on a golf course, and how well do you think you're going to hit the ball the first time once you've watched those beautiful videos? Well, I can tell you, you're probably going to miss on the first attempt. Not as easy as it looks. And if you're as lucky to hit the ball on that first thing, you're probably going to send it along the ground about 20 yards. Not the 300 yards that Tiger Woods routinely knocks it down the fairway. Okay? And what has to happen is basically the best way to improve your golf game is you're there with a golf instructor and you're swinging and they say, oh, you're pulling your head up as you swing and you're not staying on the ball. You're not keeping your head down looking at the ball. So where the big help comes is when you have one-on-one instruction. And I find that's the same thing with programming. So this is a big class. I do also know that not all of you will always show up, but there are a couple of things. First of all, we'll allow you to work on groups on certain exercises, and I'll allow you to help each other out. So it tends to work pretty well, and I've had good feedback about it. I don't have good grade statistics in here, but in CS102, I've seen about a 2/3 letter grade improvement from using the so-called flipped or inverted classroom. So I like it. Every semester, when I've done surveys, about 2/3 of the students like it, and 1/3 of the students prefer the traditional lecture format. It's very consistent. So if you prefer the traditional lecture format, I apologize, you're not going to get it in here, but I really do think the flipped classroom approach works better. Now, as I said, in order for that to work, you really do need to try to watch these videos before you come to class. In general, I try to hold them to about 40 minutes or less. And there are certain tricks that you can apply. They are on YouTube. And if you did not know this, YouTube has a special thing that allows you to change the speed of the audio. I find that I sound good at 1.5. Okay? 1.25 may be a bit too slow, but you can set it to your own speed. But setting it at 1.5 means that a 40-minute video becomes a 27-minute video. Okay, so let's speed it up here. And it just, I don't know. Maybe it's because I know how I sound, but I find 1.5 is good. You may find different speeds are good for you. You have to do something in YouTube, I believe, to enable that speed up, but you can Google it. I'm sure you can figure it out. The advantage of these lectures is if your mind wanders, you can always rewind and view them. You can view them before exams or while you're doing your homework. If you miss a class, obviously, this is a way that you still get the material. So I find that the videos work very well. Okay. Now, the textbook, I assign it because I find that some people do like to read it. You're free to read it or not read it. I think my notes are pretty good. There's only the occasional thing where I really think Scott does a better job than I do of presenting things, but it's a fallback in case you need to know it, and there are sometimes questions asked from the book. Now, do you need the most recent version of Scott? Probably not. You do need to make sure that when I assign a problem out of the textbook and you have an earlier version, that you get synced up. That may require going to Piazza. We'll talk about it in a moment, getting someone to post the questions for you. Okay, so we've gone over what is the kind of format of class. So the homework, basically there's no projects in the class. We just have a series of homework assignments. You go, you can see when they are. You can see the grading guides so that you can make sure that you have dotted your I's and crossed your T's. I am trying something different this semester. Usually I've made my homeworks due at 5 p.m. or 11:59 p.m., but I heard that one professor has tried making them due early in the morning for night owls. And I know that a lot of you are night owls. So I'm experimenting with making the homework assignments due at 6 a.m. this semester. Now, you may want to write something down. When you see due Wednesday, January 27th at 6 a.m., for most of you, what that really means is it's due Tuesday, January 26th, when you go to bed. Okay? And I am not, you can write this down now, because I'm not going to be sympathetic to the email that says, I saw that the due date was Wednesday, January 27th, and I thought that I had all day to do it. I didn't realize it was 6 a.m. So please write it down now that when you see that the homework is due on a certain date, it's really due the day before, except that if you're a night owl, you have until 6 a.m. to work on it. Okay, so we're going to see how that goes. Now, obviously, I don't plan to stay up that late, so you're on your own when you do that. In fact, I do not tend to read a lot of email in the evening, so I try to finish reading email by 6 p.m. Okay? Now, that doesn't mean that you're totally on your own if you, before I get off of that, let me do a couple more things with the homework. First of all, late policy and early policy. So, you have up to 2 days late to submit homework assignments, but each day late will be a 10-point deduction. So, if you hand in this homework, this first homework, between 6 a.m. on January 27th and 6 a.m. on January 28th, it will be a 10-point deduction, 20 points if it's 2 days late. Now, I also wave a carrot to try to get you to do it early, because I find that procrastination is not a good thing. So I award you 5 bonus points if you submit your homework more than 24 hours in advance of the deadline. Now, you can't modify it thereafter, so if you make multiple submissions, we will grade you off your last submission. But if you can get it in more than 24 hours in advance, you'll get 5 points of extra credit. You may also work with a partner on the homework assignments. That is one partner, not multiple partners. You do not have to. Okay? You are free to work on the homework assignments by yourself. Many people prefer it that way, but there's a couple reasons for that. First of all, TA support has been pared back in the engineering college, and so we have 80 students and a 10-hour TA for this course, and he can't really grade 80 homework assignments in 10 hours. So it would be nice, actually, if you paired up and you reduced his workload. If you do pair up, please indicate in your submission on Blackboard who the two of you are. Okay, don't make 2 separate submissions. Make one submission. And when you submit in the box, the comments box, tell us who you are. Okay? And in class, please try to then sit together, because if you're working on homework assignments, you can pair up like that and work together on it. Okay. So, any questions thus far? Yes.
Does this mean that you and your partner are submitting one homework assignment, or are you each submitting your own homework?
No, you're submitting one. That's why I said please don't make 2 submissions in that case. Just make one submission, and in your submission say it's Brad Vanderzanden and Yifan Tang. Okay? And then Raihan Pathan, I don't think he's here. Is Raihan here? Oh, you are here, Ryan. Sorry. No, but Raihan is here. So in fact, going to have Raihan stand up. So Raihan is our TA for the course. So also probably have Raihan have about an hour of office hours. Yep. And actually, Ryan, if you want to take off, you can. You can stay here too, but not. Okay. So so just let him know, and then he can do that recording, and he doesn't have to try to do all the paperwork. Now, that said, if you're working with someone, it is a trust issue. You got to make sure that if your partner's submitting it, they submit it. I'm also not going to look favorably upon the argument that Brad forgot to submit it. He was supposed to. Can you give me my points back? No, I can't. Okay? So it is a team effort. Yes?
Does that apply to the quizzes?
No. Quizzes you should do by yourself. Okay, I want you to do the quizzes by yourself. And we'll get to that in a moment. Okay, other questions? What? Yes?
So, so only one person, if you're doing your homework with a partner, only one person will submit on Blackboard.
Correct.
But both people seem to be in the conversation.
Yes. So in Blackboard, when you submit, there is a way to give a comment. See, it says add comments. In the submission, just here say, I did the homework with such and such. Other questions? Okay, so moving on. The discussion forum for this class is Piazza. So please, at some point, even while I'm talking perhaps, go to the Piazza sign-up link, sign up. I'm not going to be doing announcements via Blackboard. I do announcements via Piazza. Okay, I just find it's a better discussion forum. If you have a question about the homework, don't send it to Ryan. Don't send it to me. Please post it on Piazza. The reason is that I want consistency. If it's happened in the past that someone sent a question to me, someone else has sent a question to the TA, we've answered differently, it's created problems. If you post your question to Piazza, Ryan and me have an opportunity to both answer. We keep the answer consistent, and everyone also can see that question and the answer to it, so we don't get the same question asked 5 different times. So before you ask a question, please go to Piazza. It's possible that that question has already been answered. At the end of the semester, I definitely look favorably on those people who have been actively participating in Piazza. It's one of the criteria I use to decide if I'm bumping your grade up, if you're on the borderline. So I definitely appreciate it when you hop in there, try to answer other people's questions. Also, since I don't typically look at email after 6 p.m., on the evenings you tend to be on your own. Also on weekends you may well be on your own. But other students may well also be on Piazza, and they may be able to answer the questions that you're asking. So please do sign up for Piazza. That's where I will be making the announcements for this class. And that's where I'll be answering questions about homework, about quizzes, about such and such. Now, there are times when you do need to send me personal email. If you think that you've been wronged on a quiz, okay? Even though these quizzes have been done for 2 or 3 years, it still seems that every semester I still have a quiz out there that has the wrong answer. So if you think you've been wronged, send me email. Yeah, Ryan's going, But it did happen last semester. After 2 semesters of using it, I still had an incorrect answer. So, if you have some kind of issue with not being able, having to have an extended medical absence, things like that, definitely email me. If you have a question with your grade, send it to Ryan. Okay? If you send me a question about your grade, I'll send it to Ryan. Okay? So he's the one who deals with grade questions. If you have a question and it involves code, you can post privately on Piazza, meaning that no one else sees it but the instructors. Please do that. Okay, it's still better than sending it to me or sending it to Ryan, because one of us can get to it quicker. Plus, there's going to be some undergraduate TAs for the course as well. So by posting it to Piazza and just making it visible to the instructors, you'll get a faster response than if you send it to any one of us. Okay, I'll have this afternoon, I'm meeting with the undergraduate TAs for 140 and 365, and we'll figure out who's TAing what, and we'll get that information up. Okay, exams. We got sample exams for you from last semester, not last semester, last spring. And the first midterm, guess when it is? I'm sure most of you already know. It's right before spring break. And then the final is Friday, May 6th. Let's see. The plagiarism policy, please read it. I know that certain answers from the Scott book are already on the internet. I know that certain of my answers are floating in the ether out there. If we should happen to see those answers in your homework assignment, you will get a 0 the first time you do it, and you'll get an F the second time you do it. Okay? The homework aren't worth a huge amount of your grade. We'll go over that in a moment. What's important are that you know the material for the midterm and the final, which is worth 50% of your grade. So just copying something off the internet isn't going to do you a whole lot of good if you don't understand it. So submit your own work. Okay, if you're working with a partner, then it's fine that the two of you have worked together. Okay, but code prepared by a professional service, answers prepared by a professional service, answers that you copy off of the internet, that's all not permissible. If you do your work on the machines here, please make sure that you protect your directories using the change mode command. If two people hand in the same assignment and you claim that X copied off of me, I don't know that. I mean, you may say I accidentally left my directory open. Well, maybe you did, or maybe you didn't. Okay, so basically, unless I get an outright admission as, yeah, X gave me his homework, or not even that. If X gives you your homework, X is also giving you a 0 because X should not be giving you your homework. But if you say, oh, X left their directory unprotected and I got it, yeah, I'll tell X to close their directory and I'll give you a 0. But in general, both sides will get a 0 if I see that there is copying. Okay? There's just no good way to adjudicate it outside a direct admission that one person is the aggrieved party and one isn't. Okay, and then like I said, the useful guide to Java errors prepared by someone at an Israeli university, and it is but very helpful. A lot of errors, like I said, that you may not be familiar with that he goes over. So if you just look at the table of contents, you can find it. For some reason, he did not make it an HTML document, which is too bad, but it's still helpful. Okay, so we have homework assignments. The first one isn't really assigned for about another week. We also, and please write this down, have quizzes. We have quizzes. Not today, but starting next Tuesday, have quizzes that are due 46.5 hours after class. Okay, so they become available on Blackboard at 12:30 p.m. They are due 2 days later at 11 a.m., which is right before class. So the reason it is 46.5 hours earlier is so that you don't sit there and work on your quiz on Thursday while I'm droning on. Oh, I mean while my scintillating lecture is going on. Okay. So that's why they're due at 11 a.m. 2 days later. Please, do what you have to. Put it in your calendar. Tell your boyfriend or girlfriend to remind you. Tell your friend to remind you. Set an alarm on your cell phone. There's so many different ways that you can remember this, but you need to kind of just get in the habit that kind of right after class, there's these 20 minutes, that's how long they are, 20-minute Blackboard quizzes. They're not hard. What they're meant to do is just get you to rehearse the material a short time after the lecture. Why? Because studies show that when you rehearse material shortly after a lecture, you learn it better. This is a fairly painless way for you to go about it. This isn't high-stakes testing. It's worth 5% of your grade. Okay, don't get bent. No, it's worth more than that. I'm sorry. I think it's worth, we'll get there in a moment, more like 20 or 25. But it's not, they're not painful to do. You just need to stay on top of it. Okay, so questions about that. They're on Blackboard. They just become automatically available. Okay, let's see. That's wrong. General information. Okay, so my office hours this semester are Tuesday and Thursday. Ryan, I know this isn't right. You can give me. I think your room's right. Yeah, but these are old office hours. We'll get them updated. My office hours are Tuesday, Thursday, 3:30 to 4:30. Occasionally we have faculty meetings on Thursday during that time. If so, I'll let you know. But otherwise, I'm there in my office for you. Mingal 312 is where I reside. Okay, as I said, we used to flip classrooms, so I do think that it behooves you to show up for class. I don't recommend getting a Java book. There's so many good online resources available. So there's the Java tutorial site that you can go to. There is, and in fact, some of the lecture notes point you to the Java tutorials, so they have all kinds of good tutorials. Plus, they have the Java API site, which is where I go. Quite frankly, it is difficult to memorize everything in Java. It's a huge language, so I find that I simply go to this API. I have it bookmarked because I use it so frequently. We will be using Java 1.8 in this class. That is the version running on the Hydra machines. When you submit your homework assignments, please make sure that they're running on the Hydra machines. You may well have a more recent version of Java than the one running on the Hydra machines. The one on the Hydra machines tend to be a little bit out of date. And what has happened in the past is that, especially when we're making the transition from 1.7 to 1.8, is that students would be running a version of 1.8, and that had certain method calls that weren't available in 1.7. Ryan would run it. It would crap out on the Hydra machines because that method wasn't supported in 1.7. So please, before you submit your homework assignment, make sure it runs on the Hydra machines, because that's the machine Ryan will be using in order to grade. Am I correct, Ryan? Or are you going to run on your, well, okay. Well, you're running Java 1.8. Okay. So at the very least, you need to look at what the Hydra version is, because that's the one that, if the students, I'll give you this guarantee. If it runs on Hydra and Ryan takes points off because it doesn't work, you may resubmit it and Ryan will run it on Hydra, and if he verifies it works, you'll get your points back. Okay, so if you absolutely, positively must have a book, I like Herbert Schilt. This beginner's guide or Java 2, you could probably get them for cents now, or a couple bucks, because they're probably 10 years old. But Java, the basic language, hasn't changed that much. So if you get a 10-year-old book, save lots of money, and it's still pretty much going to be what you need. Okay? Rather than spending $80 on the latest, hottest book. But like I said, I think you can get everything you need from the web, so try that before you buy. Okay, how do we break down the grades? Quizzes 20%, homework assignments 30%, midterm and final 25% each. Final is not comprehensive, covers only what we've covered since the first midterm. you'll note that I throw out your 3 lowest quiz grades. So, in fact, what I do is I just take your total quiz score and divide it into n minus 3. So if there's 23 quizzes, I divide your score by 20 rather than 23. What that means is if you're diligent and do every one, you can get some extra credit. If you're not, you have the flu, you have a conference, you don't have internet connection, you just simply forgot, you get 3 do-overs. For that reason, the answer is always no when you ask me if you can have an extension on a quiz. It's just no. Okay, I'm not trying to be hard-hearted about it. It's the easiest, I've found it's just the easiest thing to do. I don't have to make all decisions. If I extend the quiz, other people can hop in and submit late. It becomes a nightmare. This is just the easiest way to handle it. It gives you a cushion. If you miss one, don't sweat it. Yes? Not really. The 3 is meant to cover even that. So that's why I said flu, death in the family. I mean, 3 is a pretty big number. That's a week and a half of classes. So even I think death in the family is probably not going to take you that much time. Other questions? Okay. And this is just actually, I said earlier what language paradigms we're going over. We also do some stuff that you may not seen a lot of. So we go through exceptions, modules, generics. Dr. Planck and Dr. Greger have very different ideas about what to teach you when they teach you C++ in 140 and 302. If you've taken Dr. Greger, I suspect you've seen a bunch with templates and inheritance. Am I correct? If you took Dr. Planck, I bet you haven't. He probably did not show you how to create it. While you've used template classes, he probably never showed you how to create a template class. Correct? And I'm sure that he thinks inheritance is a pile of you-know-what, so he probably hasn't shown you much with inheritance. I'm not sure if Dr. Greger or Dr. Planck cover exceptions. Is that true? For Dr. Greger, does he cover exceptions? No. So Dr. Planck, I'm sure, doesn't either. So these are things that you will be seeing that for those of you who have seen it in Dr. Greger's class, well, it will be review, but I have to assume that you haven't seen it because many of you took Dr. Planck. I saw a question somewhere in the back. Yes. Yes. So he thought that C++ was an abomination when he first started using it. I used to like to go around hissing like Darth Vader and tell him that, Luke, my son, you will come over to the dark side. And eventually he kind of came over to the dark side, at least to the point of view that he thought the STL was pretty cool. So he now uses the STL, so he has parts of light and dark in him now. But kind of like, who is the name of the person in Star Wars who was tortured in the current one because he still has elements of the light in him? Thank you. And that, not much of a spoiler alert. If you haven't seen it by now, then you're probably not seeing it or not a big Star Wars fan anyhow. Okay, so, yeah, he's pretty hardcore old school, though. You should have known that, though, right? Or did you not take Planck? Curious, did you take Planck or not? Did you have Planck or Greger?
I had Greger, and then I had system programming with a different professor.
Okay, so, because if you'd had Planck, he would freely tell you that he is old school. He uses VI, he swears by it, doesn't use anything newer, so yes, he is old school. Okay, so we covered that. We also cover some implementation issues. For example, how garbage collection gets implemented, how the virtual methods get implemented. some other cool stuff along the way. So, questions, comments? Yes. 2 quizzes a week. So there's no quiz today, but starting on Tuesday, and I'll remind you on Tuesday, but I'm not going to keep sitting here every day telling you, please do the quiz. So on the day of a midterm, obviously you don't have a quiz, but even on March 8th, which is right before the midterm, you still have a quiz after that particular class. So they're just there, they just come up. I've already set all of them up. Other questions? Yes?
So in reference to this course and being familiar with linked list tags and objects like that, yada yada. For somebody who, say you're doing a minor like me, and you basically the last time you programmed was maybe half a year ago,
Uh-huh.
what would you suggest I go back and review outside of those objects, just so I'm prepared next Tuesday, so I'm not asking you questions that I don't know?
C++. Okay, Java is a lot like C++. So I kind of go in assuming that you know what C++ is, and starting from that, I tell you how Java differs from C++. So honestly, until we get late into this course, that's not true. You need to know about trees and linked lists, but you don't have to know how they're implemented. You just have to know how to use them. Okay? So, yes, you're welcome. And you wouldn't be any so different than someone coming off of summer where it's 4 months. So you're not that far out of practice. You shouldn't be too worried about that. Other questions? Okay. So, I am taping today's lecture. I'm not going to tape lectures in general because, like I said, I used a flipped classroom. So the videos, they're already up there. You can watch them at your leisure. I will post today's lecture just in case people missed it or you want to go back and review it. Okay, also, I guess there is this example code. So sometimes when you're doing homework assignments, I may make reference to that example code, or during a lecture, video lecture, I may make reference to example code. So feel free to use this, take it and modify it, etc., etc. Okay, so today I just wanted to kind of give you a quick overview, high level, of the differences between Java and C++. And then we'll get into the nuts and bolts of it starting next week. Okay, so Java evolved from C++. James Gosling developed it at Sun. And does anyone know what Java was developed for? Because it wasn't developed for the internet. It wasn't developed for general purpose programming. It was developed for set-top cable boxes, something that only became widely used in the last few years. So Sun was only about 25 years, maybe 20 years ahead of its time when it came up with this language for programming cable boxes. However, right as they were coming up with this big flop, the World Wide Web made its guest appearance, and the group that developed it quickly pivoted and realized that it was equally applicable to the web because it was something meant to be transmitted kind of over the air and into someone's house. And so they quickly pivoted it and called it Java, brought it out. It was an instant hit. In fact, it was such an instant hit because it was simpler than C++. And it turned out that a lot of programmers that could not understand how to program in C++ could program in Java. Okay, at that time, there was another trend emerging, which is a lot of businesses were embracing object-oriented programming, but they found that their programmers that were educated in business schools were not capable of dealing with C++. They'd been taught how to program in COBOL. and they didn't know they could not learn C++. It turned out that a lot of their programmers could learn Smalltalk, but it was kind of quirky. So Smalltalk was kind of starting to catch on, and then out comes Java. And Java's like C++, but it's easier. And a lot of it turns out a lot of their programmers kill the cell phone. Only I get to listen to my cell phone in here. Good idea. Okay. So they found that the programmers could use Java. So very quickly, they realized that they were onto something good. They actually expanded the language so that it could be used for general purpose programming. And from there, it gained large market share. What I often tell students is just like there's engineering calculus and business calculus, C++ is like engineering calculus, Java is like business calculus. So Java is a lot easier to use in my opinion, and in the real world it's been borne out. But I'd also tell people is if you know C++, you can learn Java. But just because you know Java doesn't mean you can learn C++. Anyone know, I know we haven't gotten into it, but does anyone know what kind of is a fundamental difference between C++ and Java? Yes.
In Java, you have automatic garbage collection and array axes or bounds checked.
Right.
You have to manage memory manually, and array axes are not.
Very good. So it comes down to memory management. In C++, you have to do memory management, which means you have to have a low-level, be able to think in low-level terms about machine architectures. It turns out that a lot of people who have not been trained in that, for example, who have not taken a course like 130, Computer Organization, do not have a good feel for how the guts of a computer works. If you do not have a good feel for how the guts of a computer works, you're going to struggle with C++ because you're going to have issues with memory management. You're also going to have issues with understanding the difference between what we call objects allocated on the stack versus objects allocated off the heap. Whereas in Java, as we'll find out, objects are always allocated off the heap. So Java makes a lot of simplifications and abstracts away from this bare metal machine, which C++ kind of forces you to understand. And that's why Java, at its heart, is a lot easier than C++ to learn. Now, another reason Java is easier to learn is that they had about 10 to 15 years of experience with C++, and they knew what the flaws in C++ were, and they went about correcting those flaws. So, for example, C++ has multiple inheritance. I'm not going to call that a flaw, but it's unwieldy, it's hard to implement if you're a compiler writer, and it's rarely used. And so Java eliminated multiple inheritance and went with something called single inheritance. Originally, Java got rid of templates. They thought that that was too complicated. Eventually, they discovered they had oversimplified and that templates had their place. But when Java came out with its own template mechanism, it was a lot simpler than the C++ template mechanism. So Java simplified a lot of the C++ complexity. So what are the big differences? Okay, so the major differences. And you'll find that I abbreviate a lot. So major diff between Java and C++. The first and biggest one is in memory management. Okay, so there is garbage collection. There is no explicit memory reclamation like you do in C++. Specifically, there is no delete command. So Java takes care of deallocating all memory. As soon as there are no memory references to a block of memory, it gets collected. there's no explicit pointers. Now, Java uses pointers, and we'll talk about how they use pointers, but you cannot get at them. In C++, you can increment or decrement a pointer. You can't do that in Java. Right? There's ways to reference and dereference pointers in C++. There's no syntax for doing that in Java. And finally, Java eliminates value or stack allocated objects. So Java eliminates stack allocated objects, what I call value objects. Okay, what that means is that if in C++ you can say something like int a of 10, and what happens is a stack frame is allocated, and it has the array A with 10 entries allocated on the stack. Okay, in Java, that's not the case. In Java, what happens is, first of all, and we'll get to it, you do not show how many elements it has, and secondly, it is a pointer. So even if you declare it like this in Java, all that you get on the stack is a 4-byte pointer. And it's going to point to some object on the heap. Now initially, because we didn't assign it anything, it's null. It's a null pointer. If you try to access it right now, you will get an error message. So you have to later say something like a equals new int 10. Okay, so you have no stack allocated objects in Java. All objects, including arrays, are allocated off the heap. Okay, so those are the three major memory changes that Java makes. Second big change is in project management. So Java has a module mechanism called packages. And what they do is they allow a number of classes to collaborate with each other, to examine each other's implementation. So in C++, let's say you want to implement a linked list. Okay, so you have a linked list. So typically you declare that as a container object. That's the STL model. So you have a container object, and the container object wraps a list. This object is itself a class called something like a linked list node. These two classes are related. They would like to know each other's implementation. So even if the linked list node has declared something as protected or private, such as its value field or its next field, the container object might still like to be able to get access to those two fields. And that's actually desirable, that it be able to get access to those two fields. Does anyone know in C++ how you manage that if those fields are protected and it's not using methods? Friendship. Okay, it turns out that friendship is a pretty clunky mechanism because friendship isn't two ways. So just because I say that a linked list is a friend of a linked list node, that doesn't mean that linked list node is a friend of linked list. And in general, if you have n classes, you require roughly n squared friend declarations if you want them all to be able to share each other's implementation. That's pretty clunky. Okay, we'll get into more of that later. With Java, you can simply say they all belong to the same package, like a linked list package, and then all the classes in that package share their implementation. It's like their variables are public to each other, but they're protected outside the package. So it's a much nicer way of handling related classes. Okay. Second thing that it does, that's A, is that there are no .h files. So in C and C++, you typically put what in the .h file? What goes in the .h file? Methods, but what types? Prototypes. API. So it's function declarations, prototypes, the API for your program or for a class. What you put into the .c and .cpp files is what? Function definitions. Okay, so implementation goes into the .cpp files. API information goes into the .h file. That separates the two. The Java designers thought this wasn't particularly good. Now, this is also back before IDEs became real popular. IDEs kind of simplify the flipping back and forth between a .h and a .cpp file. But nonetheless, they felt it was better if you put all the information in the same file. So in Java, the API information is in the same file as the implementation information. And in particular, in Java, when you define a class like foo and you define a method, say like add, you provide the function definition right then and there, always. So the class or every function is declared, and as soon as it's declared, you provide a function definition for it. Okay? In Java, we'll find you typically have one class per file, and you'll find that the class name must match the file name. So if I have this class name foo, it must go into a file named foo.java. So the suffix is .java, and the name of the file must match the name of the class. Don't do that, you'll probably get a compile error, actually. You don't put multiple classes in the same file. It is okay to nest classes. Sometimes you do that, meaning you put one class inside of another class. But if you have two separate classes, you put them in separate files. Just get used to it. It's the Java way of doing project management.
So the nested class would go to the outer?
So if you had a nested class, it would be as though here, inside of foo, you might put class, so after this, you might have class goo, and it is nested inside of foo. This file is named foo.java, and if you compiled it, you would find that you would have something like foo $goo.class. It generates a .class file, and it just, because goo is nested in foo, it generates that. Now, let's say that you don't, that goo is a totally independent class. Okay, and you compile it in foo.java. It will compile both of them, but it's just considered bad form to do it. For one thing, some of Java's documentation and source tools, when they go looking for things, if you give it a class goo and it's looking for source, it's going to look for a file named goo.java. It can't find it because it's in this class foo. So it screws up Java's project management software. It's kind of meta software if you stick goo into this foo class. It's totally, Java's project management is highly dependent on this idiom that the class name matches the file name. Then they've built a whole project management structure out of that. So to go against it is to cause problems. Okay. And the last thing is that Java does not require a makefile. As long as you set it up in this way, Java does not require a makefile. It will automatically figure out which files have changed, and it will recompile them for you. But it only works if you follow these rules. If you don't, then you might as well make up a makefile because it's not going to handle stuff correctly. So that's what I meant. All of this works seamlessly if you follow the rules, and if you don't, it breaks hideously. Okay? So if you compile a .java file and that .java file uses some other classes, then the compiler will automatically go out, find those other classes, compile them as well if necessary, if they're out of date. And it will do a depth first search through those classes as well, and everything gets compiled as it should. Okay, I am actually not going to talk, I'll let you read about the inheritance difference, but I'm not going to talk about it now since that can be difficult if you've not yet had inheritance. So other language differences that are going to seem a little odd. Okay, functions cannot exist outside of classes. Even main goes inside of a class. So even main is embedded in a class.
C# and Java have the same syntax?
C# and Java they have similar syntax but not identical. So C# was Microsoft taking a look at it and saying, gee, we need to have something proprietary. And they felt Java went too far in abandoning memory management. So C# gives back partial memory management control to the programmer. Whether you like that or not, I guess it's up to you as a programmer. So C# is a Java derivative, not exactly the same, but similar. I mean, they're all in the same class. Okay. And actually, I don't know C# that well, so I don't know if functions can exist outside of classes in C#.
I think it should be inside too.
Okay. Let's see. Okay, formatted input and output is not as easy in Java. Okay, the reason for that, anyone know why formatted I/O may not even have been originally in Java? Think back to what its intended use was in a cable box. Keyboard, there's no keyboard associated with a cable box. So Java wasn't designed, not only does the cable box not have a keyboard, it doesn't have a console that shows output. So there was no reason for Java to originally have formatted I/O. And then when it was adapted to the internet, well, even then the internet was more graphics, not really, and it was mouse clicks. It wasn't really, the World Wide Web isn't really typing into a console window or outputting to a console window. So even when they adapted it to the web, there wasn't really this idea of taking input from a console window or outputting to a console window. It wasn't until it became popular among business programmers that they realized they needed to add console support. So they did, but because it's an afterthought, it was retrofitted onto the language, it's clunkier than it is in C or C++. Now, Java is also clunkier in a good way. Java was concerned about internationalization. They wanted, if you were in Europe, they have a different way of representing numbers. So they use periods, I believe. Forget what it is, but if you are doing numbers, they use periods rather than commas. So if you're in Europe, they would rather that it print out in the European format rather than in the American format. Or if you're in a country that where writing is right to left rather than left to right, they'd like output to appear right to left. So they provide various formatting classes where you simply say this is what the output should be, like a decimal number, and based on the country in which the computer is running, it will output the appropriately formatted output. So that's called Java's internationalization, and it's very helpful in terms of getting output that is appropriate, is regionally and culturally appropriate, but it's also clunkier to deal with. Okay. The last thing, and we'll get into this more next time, is the environmental issues. Okay, so fundamentally, this isn't always true, but at the way it was designed, Java interprets. Java programs are interpreted, not compiled, or executed using an interpreter. That is called a virtual machine. So what actually happens is the Java compiler converts a program to what are called bytecodes. And these bytecodes are the assembly language for the virtual machine. And get used to me writing VM for virtual machine. So the virtual machine is just a fancy name for an interpreter. The bytecodes are a fancy name for assembly language for the interpreter. As long as that virtual machine is implemented on your Windows box or your Macintosh or your Linux box or your Unix box, the Java program should be portable across platforms. So the only platform-specific piece of code is the virtual machine. That has to be implemented in the native code of whatever platform you're on. But the Java program that you write, the bytecode that is converted to is platform independent and will run on any Java virtual machine. That's what made it so useful for the World Wide Web, is no matter what box you were running, a Windows box, a Macintosh, a Unix box, the browser running on that box, as long as it could access the Java virtual machine, it would be able to execute that Java program. Okay? Because Java programs are interpreted, they're usually about 2 times slower than a corresponding C or C++ program. And next time, I will continue the discussion with why the interpretation is slower. And even if you can compile it, which is what some compilers do, why you still are going to be slower in Java than you are in C or C++. One final thing. If anyone needs me to sign an ad slip, I'm happy to do so.